You're listening to DTFHN for February 11th, 2026. I'm your recursively compiled host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who build the future argue about whether it should exist. Today's got that particular energy where everything old is new and everything new is already on fire. Let's get into it. In 1995, Microsoft made a decision that seemed inconsequential at the time. They embedded Internet Explorer into the Windows shell, not as a separate application you could choose to run, but as a rendering engine woven into the operating system itself. File dialogues, help windows, even the desktop. All powered by the same HTML engine that browsed the web. It was a convenience. It was also the beginning of a decade-long parade of remote code execution vulnerabilities that cost billions and spawned an entire industry of exploitation. Now consider what just happened with Notepad. For nearly 30 years, Notepad was the closest thing Windows had to a philosophical statement. It opened text, it displayed text, it saved text, no parsing, no rendering, no interpretation. It was a tool so deliberately simple that security researchers used to joke it was the only Windows application you could trust. The attack surface was essentially zero. What are you going to exploit? The word wrap toggle. Then Microsoft started adding features, markdown rendering, AI integration, rich text capabilities inherited from the recently retired WordPad, each edition reasonable on its own, each one expanding the attack surface of an application whose entire value proposition was having no attack surface. The vulnerability itself is almost poetic in its predictability. Open a markdown file in Notepad, click a link. The application launches an unverified protocol handler that loads and executes remote files. The same class of vulnerability that plagued Internet Explorer 20 years ago, now living inside the one application that was supposed to be immune. The biological analogy here is the immune system. A healthy organism distinguishes self from non-self. It knows what belongs and what doesn't. Notepad's immune system was perfect precisely because it had no foreign surface proteins. It couldn't be tricked into executing something dangerous because it couldn't execute anything at all. The moment you graft on markdown rendering and protocol handlers, you've introduced exactly the kind of complexity that pathogens exploit. You've given a simple organism a transplanted organ without the immune infrastructure to protect it. The HN comments get this exactly right. One commenter nails it. Notepad had one job. The feature bloat to vulnerability pipeline isn't a bug in the process. It's the process itself. Every feature is a promise to users and a gift to attackers. This matters beyond Notepad. It's a case study in why the Unix philosophy, do one thing well, isn't just aesthetic preference. It's a security architecture. Small composable tools with clear boundaries are inherently more defensible than monolithic applications that keep absorbing capabilities. The tools that survive aren't the ones that do the most. They're the ones that know what they're not supposed to do. Moving on. Steve Yeager's latest piece is called The AI Vampire, and we only have the title and the comment thread to work with here, but the comments tell us plenty. Let's start with the fundamental economics. One commenter mentions Jeffrey Emanuel spending $4,400 a month across 22 AI coding accounts, 22 accounts. Let that land for a moment, not because the number is shocking, but because of what it implies about the unit economics of AI-assisted development. If a single developer needs 22 subscriptions to match the productivity gains Yeager is evangelizing, we're not looking at democratized tooling, we're looking at a new cost floor that prices out exactly the people who were supposed to benefit. The comments reveal a community splitting along a fault line. On one side, experienced developers who've survived enough hype cycles to recognize the pattern. A technology that genuinely works being wrapped in rhetoric that overpromises. On the other, the reality that junior positions are vanishing. One commenter puts it plainly. AI takes jobs faster than it creates new ones. No junior roles available. Only the developers who already had seats at the table get to use these tools commercially. This is a bootstrapism problem. The ladder is being pulled up in real time. If AI coding tools are genuinely powerful, and the evidence suggests they are, then the question isn't capability, it's access architecture. Are these tools being built so that a student in Lagos and a senior engineer in San Francisco have the same leverage, or are they being built so that the senior engineer becomes 3 engineers and the student becomes irrelevant before they start? Yeg has historically been one of the sharper voices in the industry. His old blog posts on platform thinking and service-oriented architecture were genuinely prescient. Several commenters note the shift in tone. One says he lost it, another identifies it more precisely as addiction. The particular kind of enthusiasm that comes from being so deep inside a paradigm that you stop seeing its edges. The interesting technical question buried under the discourse is whether AI coding assistance is fundamentally a productivity multiplier for existing expertise, or whether it can genuinely compress the learning curve for new developers. The comments suggest the former, the marketing suggests the latter. The gap between those two claims is where careers go to die. The tools exist. The question is whether the business models around them are designed to distribute capability or concentrate it. Moving on. Let me make the strongest case against caring about the Feynman lectures in 2026. They're 60 years old. Physics has moved on. We have interactive simulations, AI tutors, YouTube explainers with production values Feynman never dreamed of. Why would anyone work through 3 volumes of lectures delivered to Caltech freshmen during the Kennedy administration? Now, let me tell you why that argument collapses under its own weight. The Feynman lectures aren't a physics textbook. They're a demonstration of what it looks like when someone understands something so completely that they can rebuild it from scratch in front of you. And Caltech made them free, fully open, no paywall, no login, no tracking pixel, just the entirety of one of the greatest pedagogical achievements in science, sitting on a server waiting. One of the commenters nails something that most physics students discovered too late. They tried using Feynman during university and found it useless, because their classes were about memorization, not understanding. That's not a criticism of Feynman, that's an indictment of how we teach physics. The lectures assume you want to actually think about why nature works the way it does. Most curricula assume you want to pass an exam. Those are fundamentally different projects. What deserves genuine admiration here is the craft of explanation itself. Listen to the audio recordings, especially the bits before and after the formal lectures where Feynman is just talking with students. You can hear someone who treats clarity as an engineering discipline. Every analogy is load-bearing. Every simplification is deliberate. He's not dumbing anything down. He's finding the path through the concept that carries the most intuition per sentence. There's a lecture called There's Plenty of Room at the Bottom from 1959 where he essentially described nanotechnology before the field existed, not as speculation, as engineering analysis. He looked at the physics, ran it forward and described what was coming. That's the Feynman method. Understand the fundamentals deeply enough and prediction becomes almost trivial. The lesser-known lectures on computation deserve attention too. Feynman, applying that same first principles clarity to information theory, reversible computing, and the thermodynamics of computation, also freely available. Here's why this matters now. We're drowning in AI-generated explanations that sound confident and read smoothly and occasionally hallucinate entire concepts. The Feynman lectures are the antidote. They're what understanding actually sounds like. The tools exist, the knowledge is available. It has been since 1964. The question is whether you're willing to do the work of actually thinking, or whether you'd rather let something else do a convincing impression of it. We talked about tools for thinking pause. Now let's talk about tools for broadcasting. Story 4, exploring a modern SMPTE 210 broadcast truck. $45,000 worth of clocks. That's what's sitting inside Mobile TV Group's 45 Flex broadcast truck, and every penny of it is justified because in live SMPTE 210 production, if your timing drifts by even a few microseconds, your video tears, your audio desyncs, and millions of viewers see it happen in real time. Jeff Geerling got behind the scenes at a St. Louis Blues NHL broadcast with his dad, and what he found is a masterclass in engineering under pressure. The 2-400 10 standard, which replaced the old baseband SDI world with IP-native video audio and metadata streams, is one of the most ambitious infrastructure transitions broadcast has ever attempted. Think about what happened when Ethernet replaced token ring in the early 90s. Same energy, but the stakes are higher because the output is live and the tolerance for failure is measured in frames. The timing architecture alone is beautiful. 2 Everts 5700 MSC Grandmaster clocks with automatic changeover, feeding PTP signals across the truck's entire IP fabric. PTP, the Precision Timing Protocol, is the same IEEE 1588 standard that synchronizes trading floors and data centers, but here it's keeping dozens of camera feeds, replay systems, and audio channels aligned to sub-microsecond precision. And here's the detail that genuinely delighted me. When Chris Bailey, the truck engineer, needs to set the master clock, he pulls out his phone and uses an atomic clock app, accurate to within a second. That's it, because unless you're synchronizing across multiple trucks at something like the Olympics, you don't need true UTC, you need internal consistency. The precision timing protocol refers to the network sync, not the absolute time reference. That distinction matters. The comments surfaced Ambwa Enmos, the open API layer that's becoming the control plane for 2,110 deployments. Vendor-neutral device discovery and connection management built on open specifications. This is how broadcast infrastructure evolves without getting locked into a single vendor's ecosystem. What struck Geerling most wasn't the technology, though. It was the atmosphere inside the truck. He called it solemn, constant, structured chatter, every word purposeful, dozens of people coordinating shots, replays, promos, all in real time. The craft of live broadcast is fundamentally a human synchronization problem, and the 2,110 stack exists to make sure the machines can keep up with the people. PTP doesn't replace the director's instinct for when to cut. It just makes sure the cut happens exactly when she calls it. Moving on. One commenter dropped the Frank Herbert quote. Once men turned their thinking over to machines in the hope that this would set them free, but that only permitted other men with machines to enslave them. And normally I'd roll my eyes at a June quote in an AI thread, but this one lands different here because Cam Pedersen's piece is doing something genuinely interesting with the math, and the conclusion he reaches is almost exactly Herbert's point, just with equations. Let's break this down to what's actually happening. Pedersen took 5 real metrics of AI progress: MMLU scores, tokens per dollar, release intervals, arXiv papers, Copilot code share, and instead of fitting exponentials like everyone else does, he fitted hyperbolus. And this matters. An exponential reaches infinity at t equals infinity. You'd be waiting forever. A hyperbola reaches infinity at a finite time, a pole, a vertical asymptote. The math actually breaks. The procedure is almost comically straightforward, which Pedersen himself flags as concerning. Fit a separate hyperbola to each metric, give each its own scale, but share the singularity time across all of them, then ask, which singularity date makes the fit work best? And here's the punchline that makes this more than a blog post parlor trick. Most of his metrics don't actually show hyperbolic curvature. 4 out of 5 are better explained by plain lines. The one that genuinely curves toward a pole is tokens per dollar, the cost collapse of intelligence. But the real insight isn't the date, it's what the pole means, Pedersen's conclusion. And this is where the comment section actually earned its keep, is that the singularity isn't when machines become super intelligent, it's when humans lose the ability to make coherent collective decisions about machines. The pole isn't in capability, it's in governance. The denominator going to 0 isn't compute, it's our capacity to keep up. Run this forward. If the binding constraint is human decision-making, then the architecture of these systems matters more than the capability curve. Open systems where the math is published, the weights are inspectable, the training data is auditable. Those give us a longer runway before that denominator hits 0. Closed systems where 5 companies hold the weights behind API walls. That's the Herbert scenario. That's men with machines enslaving other men. The singularity will occur on a Tuesday. The question is whether you can read the source code on Wednesday. 6 stories in and we're just getting warmed up. Story 6, pause, a familiar face from GitHub, is building something new. Let's pull this thread. Nat Friedman ran GitHub. He knows what a developer platform looks like. Repositories, pull requests, CI/CD, the whole choreography of humans collaborating on code. Entire.io introduces checkpoints, a primitive that captures agent context as version data in Git. The agent's reasoning, its session history, its decision tree, all committed alongside the code it wrote. On paper, that's genuinely interesting. It's version control, not just for what was produced, but for how it was produced. But one commenter nails the uncomfortable question. Are we building tools for a workflow that actually exists, or are we building tools and hoping the workflow materializes? Because right now, most AI coding looks like what another commenter describes. Spec-driven development. You write a spec, hand it to an agent, get code back. That's not a workflow that needs a platform. That's a workflow that needs a good prompt and a model with enough context window. The checkpoints concept reveals something about where the bet is placed. If you're versioning agent context, you're assuming agents will have persistent, evolving relationships with code bases, multiple agents, multiple sessions building on each other's work. That's not today's reality. Today's reality is one-shot generation with a human reviewing the diff. The platform is for the workflow Friedman believes is coming, not the one that's here. Now, the comments also surface the evergreen Silicon Valley dynamic. Former CEO of a platform worth billions needs external funding for the next thing. That's not hypocrisy. That's how the economics work. But it does raise the architecture question. Entire is a company with investors who expect returns, the checkpoints, the agent context, the session data. Where does it live? Who owns it? If my agent's reasoning is a first-class primitive, is it my primitive or theirs? The spec-driven development wave is real. People with years of backlogged project ideas are finally shipping them. The question is whether that wave needs a new platform or whether Git plus a good model is already the platform. Friedman is betting the answer is no. That something new is required. The market will tell us if he's right, but the tooling should probably follow the workflow, not the other way around. Moving on. I've built monitoring systems that watch network traffic patterns, and there's a moment every engineer dreads. When a signal you've been tracking for years just stops, not gradually, not seasonally, it falls off a cliff, and you're left staring at your dashboards wondering if your sensors broke or if the world just changed underneath you. That's what Grey Noise observed on January 14th. Telnet traffic across their global sensor network dropped 59% in a single day. 18 autonomous system numbers went completely silent. 5 countries disappeared from the data entirely. This isn't a gradual sunset of an aging protocol. This is someone flipping a switch. Run this forward. Imagine you're a tier 1 transit provider and you decide to start filtering port 23 at the backbone level. You're not just blocking Telnet for your customers. You're partitioning the internet itself. BGP can't route around it. There's no automatic failover when the physical path exists, but the port is deliberately closed. One of the commenters flagged this, and they're right to be alarmed. The precedent matters more than the protocol. Today it's Telnet on port 23. Tomorrow it could be any port that someone decides is too dangerous to leave open. 6 days after the traffic cliff, CVE 2026-24061 dropped. A vulnerability in the inetutils telnet daemon traced to a specific commit on Codeberg. The timing is suggestive. Either major transit providers got advance notice of the vulnerability and acted preemptively, or this is one of those coincidences that security researchers collect like baseball cards. The genuinely serious angle here is the governance question. Telnet is ancient, unencrypted, and mostly used by attack traffic at this point. Fair enough, but the mechanism of its disappearance matters enormously. If backbone providers are coordinating port-level filtering based on undisclosed vulnerability information, that's a capability demonstration. The Internet's routing architecture assumes that transit is neutral, that packets flow based on destination, not content or port. Every exception to that assumption is a precedent. The inetutils project, by the way, lives on Codeberg. An open source forge. The vulnerability, the commit, the fix, all visible. That's how security is supposed to work. The part that happened in the dark, the coordinated filtering across transit providers before public disclosure. That's the part worth watching. The protocol may be dead. The question is who killed it and what authority they claim to do it. Security on constrained hardware. Pause. This is where clever engineering gets genuinely fun. What does it mean for a device to prove it has permission? Not a server, not a laptop, a microcontroller with kilobytes of RAM, no browser, no OAuth stack, no room for the authentication ceremonies we take for granted in cloud computing. When a tiny sensor needs to tell another system, go download this firmware image on my behalf, how does it assert that authority? Signy answers this with elegant minimalism. It generates signed URLs directly on embedded hardware using asymmetric cryptography through the PSA crypto API. The device holds a private key, signs a URL with a validity window, and any system that trusts the device's certificate authority can verify that URL without ever talking to the device again. No token exchange, no session state, no phone home requirement. The URL itself is the proof. The format is worth examining. Base URL and not before timestamp and not after timestamp. The device's certificate in base 64 and a signature over everything preceding it. That's the entire protocol. 5 components. The time window means a captured URL expires. The certificate means you can trace it back to a specific device. The signature means nobody can forge one without the private key that never leaves the hardware. This runs on Zephyr and ESP IDF. The 2 dominant embedded operating systems. A few lines in your manifest file and your microcontroller can generate cryptographically verifiable URLs. The engineering constraint here is beautiful. When you can't afford the memory for a full authentication client, you push the complexity into the URL itself. The URL becomes a capability token, a self-contained authorization that travels through systems that don't need to understand it. They just need to pass it along to something that can verify the signature. And it's open source. Goliath built this, and yes, their cloud platform verifies these URLs as a service, but the library, the signing logic, the format specification, all on GitHub under a permissive license. You could build your own verification server, you could adapt the format. The cryptographic primitives are standard PSA, nothing proprietary in the mechanism itself. This is infrastructure-grade work for devices that cost less than a cup of coffee. The tools exist. They're small enough to fit. From firmware cryptography to something entirely different. Story 9. Lessons you will learn living in a snowy place. In 1978, Digital Equipment Corporation shipped the VAX 11 7708E with a massive documentation that most engineers never opened. The operations manual explained exactly how to handle power failures, thermal limits, environmental tolerances. Years later, when VAXen started showing up in university basements and research labs far from DEC's climate-controlled data centers, the machines that survived were the ones whose operators had actually read the manual. The ones that didn't, well, those became cautionary tales in system administration folklore. This article is that manual, except for living in snow, and I love it because it does something technical documentation almost never does. It admits uncertainty. Nothing in this life is knowable, the author writes, after describing how your power flickers back on for 3 minutes and then dies again. That's not nihilism, that's operational wisdom. Anyone who's debugged a flapping network interface knows exactly this feeling. The system appears to recover, you start to relax, then it drops again, and now you're worse off because you stopped your workaround. The engineering parallels run deep here. Snow is a distributed systems problem. Each snowflake is trivial. Accumulated snowflakes break roofs. The failure mode isn't the individual unit, it's the aggregation over time compounded by freeze-thaw cycles that increase density. The author nails this. Shovel early, shovel often, because yesterday's powder is tomorrow's concrete. It's the same principle behind incremental backups, continuous integration, any practice where letting work pile up transforms a manageable task into a catastrophic one. The comments are fascinating because they reveal the global variance. A Norwegian commenter finds power outages during storms genuinely surprising. Their infrastructure handles it. Someone from Yakutsk describes a city of 350,000 people functioning at -64 Celsius. These aren't different levels of toughness. They're different levels of infrastructure investment. The systems work because someone decided they should work and built accordingly. And the Gators section, genuine joy about practical clothing. The author is having fun, that matters, because the actual lesson underneath all of this isn't about snow preparation. It's about the gap between knowing something intellectually and having the operational experience to act on it. Read the manual, build the muscle before you need it, store the batteries before the storm. The tools exist, the knowledge is available. The question is whether you internalize it before the power goes out. From snow boots to Steve Jobs. Story 10 pours a commencement speech that rewired a generation's relationship with failure and ambition. There's a concept in music composition called the fermata. A note held beyond its normal duration, suspended in time, asking the listener to sit with it before the piece moves on. Steve Jobs' Stanford commencement address is a 21-minute fermata in the middle of an entire era's obsession with speed, scale, and disruption. The structural problem Jobs faced is fascinating from a first principles perspective. A commencement address is constrained by format, 15 to 20 minutes, an audience that didn't choose you, a setting that demands inspiration but punishes platitude. Most speakers solve this by going broad. Jobs solved it by going narrow, 3 stories, 3 data points from one life, and from that constraint he extracted something that has outlasted almost every product he ever shipped. Consider the engineering of the speech itself. He opens with dropping out of Reed College and immediately reframes failure as navigation. Calligraphy classes taken out of curiosity became the typographic foundation of the Macintosh. This isn't retrospective justification, it's a description of how nonlinear systems actually work. You cannot connect the dots looking forward. That's not poetry, that's complexity theory. The inputs that matter most are the ones no optimization function would have selected. The second story about getting fired from Apple is where the architecture reveals itself. Jobs lost control of the system he built, and his response was to build Next and Pixar. Which is to say, his response was to keep building. The recovery wasn't emotional resilience, it was compulsive creation. The tools existed, he picked them up again. And the third story, death. Remembering that you'll be dead soon is the best tool I've ever encountered to help me make the big choices in life. That's a timeout function, a constraint that clarifies the objective. Every engineer understands this. When resources are finite, you optimize differently. One commenter invokes the Buddhist concept of hungry ghosts, beings trapped in permanent craving. It's a fair counterpoint. Stay hungry can become pathological. But Jobs wasn't describing appetite for its own sake. He was describing the refusal to let someone else's loss function replace your own. Don't waste your time living someone else's life. That's not ambition, that's autonomy. And 20 years later, 120 million views later, the fermata holds. This has been your daily tech feed for Hacker News for February 11th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6, voiced by Quen 3 TTS, not affiliated with Hacker News or Y Combinator. Now go build something that surprises even you. We'll see you back here tomorrow.